we'll move on to the next speaker, Ross Reichardt. So Ross has a lifelong enjoyment of all technical things. He grew up working on his bike, which he still does, lawnmowers, billy carts, and helping his dad on the car. When it came time to work, he started with an apprenticeship in scientific instrument making, which is all about industrial process measurement and control, with CSR in Sydney. After CSR, he moved to the commercial building area where he spent 15 years working on building control systems and security systems. During that time, Ross found an interest in IT work and left the commercial building sector to work in the IT industry, mainly with database products, but also some web building work. Throughout his life, Ross has loved old cars, specifically British sports cars, which he owns 2 of. Now retired, when not traveling with his wife, Ross spends his time with Freedom Solutions, a local men's shed, and working on his cars, still doing technical work. Over to you, Ross.
Okay, thanks, Coco. Can we get my presentation up? Get it started. Up around the top left, there's the from the beginning button. Up a bit, yeah. I don't know if that's quite working yet. Yeah. Okay. So I'm here just to talk about a unique solution that I've been working on. This is really a project that's still underway. It was interesting to hear Barry's comments earlier about everything we do here is a prototype, because I still think of this as an evolving prototype, really. But it's a guitar strummer I've been working on for a while for a client of ours who's suffered a stroke. So the client, Michael, is in his mid-50s. He's married with 2 children. He was and is a passionate guitar player, and has showed me a number of videos over the time I've got to know him of him playing his guitar. He was running a successful small business when in 2022 he suffered a stroke, which has severely impacted his speech. He has very little speech, although I think it is getting better. And it's impacted the right side of his body to the point that he has no use of his right arm or his right hand, and his right leg is weaker than his left. He's tried to go back to the guitar, and to that end, his family was strumming. He can't use his right arm, so he can't strum the guitar, but he can fret with his left hand. So his family, particularly his daughter, who's also a musician, was strumming the guitar for him, but that was limiting. So he asked us, came to Freedom Solutions and asked for a device that would strum the guitar for him while he fretted the chords. Now, I knew it could be done, but I didn't know how to do it. A challenging technical feeling, which I've always quite enjoyed, actually. There must be a solution out there. How can I find it? I'm also what I would refer to as a lapsed guitar player myself. I used to play a lot more when I was younger, and I get it out occasionally now, but don't play as much as I'd like to. So I have an interest in guitars and guitar playing, and this project looked like a chance to combine my interest in technical work with interest in guitar playing. So the first step was to meet Michael and his wife, who's his primary carer, and discuss what he could do. So it turns out very quickly on meeting Michael that you realise he has no use of his right arm. So not only can he not strum the guitar, but he can't even really use his hand to trigger a strumming mechanism. So we agreed that the best way for him to control the strummer would be by his foot. That meant his left foot, because his right foot is somewhat impacted by the stroke as well. That's pretty important. We'll come back to that a bit later on. Videos, like I said, he's shown me over the number of meetings I've had with him, he's shown a number of videos to me of his abilities, and he was clearly a very capable guitar player, wrote his own music, played in a band, played in church quite a lot, and that's a point he's really trying to get back to. And it was very obvious from talking with Michael that he really missed playing his guitar. So as per the first meeting, my first attempt, and in a way it's kind of still the first attempt, it's an evolving thing, was to create a device for him that was foot operated. I thought about a mechanical solution. In fact, I think Tad some years ago built a mechanical guitar strummer for another client who wanted a similar a similar solution. And there are some plans of that device still around, although I gather not incomplete, somewhat incomplete plans. But I decided it was too inflexible. You'd need some sort of a cable system connected between the guitar and the floor, and I just thought it was going to be too inflexible. So I decided pretty quickly to build it on a thing called an Arduino Nano microcontroller. Now, I know there's people in this room that I'm in, and probably people online who are very familiar with Arduinos. If you're not, an Arduino microcontroller is essentially a tiny programmable computer, a tiny little piece of electronics that you can program, and they're applied to an enormous array of solutions around the world, all sorts of stuff Arduinos find their way into. They're very flexible, they're very available, they're very cheap. I also decided that the strummer was going to be mounted under the strings, and I'll get back to that. In researching the project, I did what probably most of us do, go to YouTube and see what else is out there. There's a number of devices that have been done that have the strummer mounted over the strings. I decided to put mine under. I'll come back to why that is in a moment. So as I said, it was going to be controlled by an Arduino Nano controller. And the pluses of doing that are these devices are really cheap. They're quite powerful, programmable, and widely used and understood. There's a whole subculture of people like me and us here who do technical work for Freedom Solutions. Technical people who understand Arduinos. They can program them, but they apply them to all sorts of problems. The points against doing something like this is it is a point of failure. If the Arduino fails, then the strummer stops. And it does require some expertise to modify. There's a little bit of basic electronics around the strummer, or around the Arduino to operate the strummer. And of course, you need knowledge of the Arduino itself. So if the device needs to be repaired or modified, have its features enhanced in the future, that requires some expertise. I actually think that's a pretty low bar. There's a lot of people in the world, a lot of knowledge out there on Arduino. So I don't think that's going to be a major problem in the future. So the solution I've come up with has two parts. There's a strummer arm, which actually strums the strings. I call it the strum head. That's the bit that's mounted on the guitar, as I said, under the strings. And then there's the pedal, which controls the strum head, the pedal that Michael uses to control it. And that houses the controlling electronics. The Arduino is mounted inside the pedal. And attached to that is a knob attached to a little box and a cable that connects down to the pedal. That allows Michael to control the speed that the strummer strums the guitar. The strum head, like I said, I put it under the strings for a few reasons. Firstly, it doesn't spoil the aesthetics. I find guitars a really attractive instrument. They're nice things to look at, and most of the solutions have these solutions mounted over the strings, which somewhat detracts from the look of the guitar. It also means the guitar can be shared by others. So an able-bodied person could take Michael's guitar and play it pretty normally with the strummer deactivated. Without actually taking it off the guitar, you can still strum, an able-bodied person can still strum over the top of the strings like you normally would a guitar with the strummer still in place. And thirdly, it means the guitar can fit into a standard guitar case to be transported. And given that Michael plays at church, that's probably an important point to him. The cons, and the major one is the sound of the motor that does the strumming is amplified. We're putting a strummer inside the sound box of the guitar. The sound box does what a sound box does and amplifies the sound of the motor. That turns out to be a major problem, which has forced a significant redesign of this, which I'll get to at the end. It can be more difficult to fit it to the guitar. You've got to push the strings out of the way to get this thing down into the sound hole of the guitar. That's not a major problem. And once I've put it on and off guitars multiple times, it's not that hard when you know how. And once it's in the guitar, it kind of tends to stay there anyway. It also means it can only be fitted to a hollow-bodied guitar with a circular sound hole. So that rules out electric guitars. Michael has an electric guitar. A little side thing, his electric guitar was made for him by a friend for his 40th birthday. And I think that speaks something to Michael as a person and his love of guitar playing. The friend would make him an electric guitar for his 40th birthday. I've spent a few minutes on that guitar too. So he has an electric guitar and this strummer is not suitable for that, unfortunately. It also means that it can't be fitted to an F-hole guitar. They're a more rare part of the acoustic guitar family. F-hole guitars have a sound hole that looks a bit like a violin's F-hole. So it needs to be a hollow body guitar with a circular sound hole. That's not a major thing when it comes to acoustic guitars. But that's part of one of the problems of having thing fitted under the strings. The strum head itself uses a standard angular servo motor, and there's a picture on the screen. If you play around with robotics or modelling, you're pretty familiar with these things. They're cheap, they're freely available. There's this particular model of servo will swing at an arc of about 150 to 180 degrees under the control of a computer like the Arduino. And being programmable, the Arduino in our application, my application, controls how wide it sweeps and when it sweeps. The servo itself is mounted on a square bar that sits, it's clamped to the underside of the soundboard of the guitar on the bottom through the sound hole. And it's clamped by a piece of wood. I'll show you a photo of it in a moment. It's clamped by a piece of wood that sits on the top of the soundboard of the guitar and clamps the servo in place in the sound hole of the guitar. To the servo is attached a short arm. The one end of the arm is screwed to the servo, attached to the servo, and the other end has the plectrum for strumming the guitar, a standard plectrum that any person would use to strum the guitar. I tried a few designs. I made a few of these arms, and there's a few of them in a picture there. But primarily, the arm needs to be inflexible. I don't want an arm that bends too much. It turns out there's a reasonable amount of force involved in strumming a plectrum across the strings of a guitar. So I don't want the arm to bend as that happens. So it has to be fairly inflexible. Also needs to be light. I don't want the weight of the arm impacting the performance of the servo motor. The one I've got at the moment is made from quite thin steel in just a basic L shape. And it seems to be working pretty well, but the ones on the right are some of my rejects. And the pink one at the bottom you see in one of the photos. So here's two photos. The one on the left is a close-up of the strummer fitted to the sound hole. Now it looks rough and ready because it's, and Peter reckons he had the worst looking prototype. I reckon I've got a challenger here. But this shows you pretty much how it's put together. If you follow the top end of the pink arm, that's where it's attached to the servo. So the servo is sitting under that piece of timber inside the sound hole and the wires are running up to it. The right picture is actually a video, and I took this as slow motion, which will show you the action of it in operation in slow motion. And I took this because I was concerned at the impact, the stresses on the motor as it strums. It's quite interesting to see, if I start this off, what happens to the arm when it strums across the string. So it will go across, see how it bounces as it strums. And interestingly, the servo is standing up to that, the rigours of that pretty well so far. So that sort of shows the action of how it works and what happens to the arm as it strums across the string. So that's, I don't know how slow that was, but obviously somewhat slow motion. Oops. Okay, the second part of the solution is the pedal controller. Now, the pedal controller is a modified sewing machine pedal bought off eBay for 30 bucks or something like that. They're freely available for sewing machines. I chopped the insides out of it, half the insides out of it, and used it to house a micro switch, which is triggered when Michael presses on the pedal. That triggers the Arduino to signal the servo motor to move. And it also houses the Arduino itself. Added to this, I don't show you in the pictures, I'll show you the pedal because it's a later addition. There's a potentiometer knob connected to the pedal by a cable. So the knob actually sits nearby Michael in his lap or on a table nearby, where he can adjust the knob to control the speed of the strumming of the guitar. There's a slight variation that triggered that, which I'll talk about a bit later on. The prototype of the pedal was housed in a Chinese food container, which became a bit of a joke. I'd go down there and I'd say, hey, I've got the Chinese food container again, and they'd laugh because it was just a quick and easy way to get a pedal working. So here's the pedal not in the Chinese food container, in the $30 sewing machine pedal. The picture on the left shows the pedal top off, obviously. You can see the Arduino mounted on a circuit board at the bottom. Just to the left, on the left-hand edge, partway up, you can see the top of the micro switch that's triggered when Michael presses on the pedal. There's a little power supply, standard sort of wall wart, we call them, that plugs into the power point. and connects in a plug on one side of it to power the unit, and on the right side there's a cable that goes up to the servo motor in the guitar to trigger the servo motor. And now there is a third cable that goes out to the knob to adjust the speed of the strumming. And the right picture is simply the pedal in one piece, how it would look. So what problems have we had? Well, the first problem is a problem of control. The pedal directly replaces a hand strum of a guitar. So when Michael presses down on the pedal, you get a down strum on the guitar. When he lets go of the pedal, lets the pedal up, you get an up strum of the guitar. So the speed and the rhythm of the strumming is controlled by Michael's foot in a similar way to a person would do strumming with their hand. The problem with this is Michael had to use his left foot because his right foot is impacted by his stroke. And his wife, Kathy, rang me one day and said, Michael's getting quite frustrated because he's having trouble coordinating strumming with his left foot and fretting with his left hand. So I think I had the strummer at home at that point, picked up my guitar, connected up and tried to do it and immediately got it. And as she said, it's a cross-brain issue. And it is a real issue of coordination, and it was becoming an impediment to him. So we decided to change the design. We just modified the device so it would strum continuously. And it was at that point that I added the knob for Michael and changed the way the device works. So now he presses on the pedal to start it strumming, and it strums at a steady tempo controlled by the knob. And when he wants to stop strumming, he just lets go of the pedal, takes his foot off the pedal. That's allowed him to make more progress with it. The problem with that is it creates a somewhat mechanical strum pattern, and I'll come back to that too. But it has solved that problem of control that he was having. The second problem with the design is the noise, and the major source of noise is, of course, the servo motor. Those things aren't quiet, and if they're stuck in the back of a model or a robot, it doesn't really matter. But when you've got it in the sound box of a guitar, it does tend to matter. There's two sources of noise from a servo in this application. The first one is the servo, because it's clamped directly to the soundboard of the guitar, tends to transmit its noise via vibrations into the soundboard. That's solved by rubber mounting it, which I did, and that significantly reduced the noise from that. The other problem, of course, is the servos make a sort of a whoosh whoosh noise as they go backwards and forward, and that whoosh whoosh noise is amplified by the sound box of the guitar, and there's really no way around that by having it mounted in. So, somewhat to my disappointment, we've decided to move the strummer out of the guitar and place it over the top of the strings, which is not what I wanted originally, but I think if it works as the way we hope, it will be a better product for it. So I'm partway through that redesign at the moment. Michael's still using the prototype under the strings that's clamped to his guitar, and he's using that. But I'm partway through a redesign to now mount it over the top of the strings. The third problem is strum variations. There's an almost infinite way an able-bodied person can strum a guitar, and the guitarists in the audience will understand this. You can do down and up strums. You can do only downs, you can do only ups, you can strum in triplets, you can do rhythmic tapping, you can do all sorts of things. It's really limited only by your musicality and your creativity. Unfortunately, with a mechanical device like that, I can't replicate that. So the strummer at the moment can only do down and up strums. And when it does a down strum, it has to do an up strum to repeat the cycle. So the way it works now is it strums down on the 1 beat of a bar, it strums up on the 2 beat of a bar, it strums down on the 3 beat, it strums up on the 4 beat. And it's fairly mechanical feel now because it's a continuous strumming done at a machine set tempo. So I can't really match that sort of flexibility of a human strumming. Maybe the new design will allow us to make some changes, to make some improvements to the strumming pattern. But currently, though, I don't know the solution to these patterns. But hey, maybe the solution's out there. Maybe we just got to go find it. A couple of videos here. The one on the left is Michael when I first brought the prototype to him. This is when it was under pedal control of the strumming. And I'll run through these. I think some people may have seen this one before. Quite like this one because the joy that he had through playing a guitar on his own again was evident.
Hey, Rose, I think the sound is not shared. Can you, Zoe, reshare with the sound, please?
Working here, Kyoko.
Yeah, probably when you share screen, we need to share with the sound. So I think Zoe can do it instead of you. Yeah.
Stop sharing and then share with
Oh, okay. So the suggestion's been made if you stop sharing and reshare with sound. Does somebody know how to do
Yeah.
this? Yeah, okay. Cool. Okay, we'll try that again. Go back.
Great. Thanks.
He was the look of pleasure on his face was something I think I remember for a while. This second one is after we change it to a continuous strum, and you'll hear the difference in this strum pattern here. It's much more mechanical in its feel, but it does allow him to play it without that coordination.
One, two, Michael, yeah. 3 and 4 and C. And E minor, excellent. When temptation comes my way.
I won't play it all the way through, but you can see that's the second one is with a continuous strumming. So in that operation, I didn't show his pedal, but he's just got his foot pressed on the pedal to keep it going in that continuous strumming mode I talked about. So finally, this has really been an interesting project. I've been on this for quite a while. It's pushed me in a number of ways. When I started this, I knew of Arduinos. I'd never worked with one, and similarly servo motors. So that was really good, really interesting for me. I've got a background in IT, as I said, so programming is not a problem, but actually firing up an Arduino and learning how to apply it to things was something I really enjoyed. Just as an aside to that, there's a similar product to an Arduino known as a Raspberry Pi. I've got one of those and I've applied that to my old British sports car as well. So it's kind of, this project's got me into that world, which I've really enjoyed. The new design is being designed in Fusion 360 and 3D printed here at Freedom Solutions, and that's a whole world I knew nothing about and still know very little about, but it's nice to get me into that too. So it's pushed me technically, which I've really enjoyed. It's put me in touch with the guitar playing side that I enjoy, and it's been enjoying meeting Michael and his wife. They're lovely people to work with. So finally, thank you to everyone who's offered their thoughts and experience. There's been a number of people I've spoken to about this, and lots of people have given me their thoughts on what we could do. That's helped a lot. I really have to say thanks very much to Marco. Marco, I know you're on the call. Marco came out with me to the last meeting I had with a client, and his first reaction was the noise from the servo motor being in the guitar is a problem. And he was right, and I knew that was always going to be a problem. And it was Marco, you saying to me, we could 3D print it that turned the lights on for me, and he's helped me with that, so big thanks there. Also to Mike. Mike's emailed me so far about working the 3D printer here, so thanks to those two guys. You're pushing me in an area I haven't been pushed, and I'm enjoying that very much. So that's it. That's thanks very much. It's been a great project. I've enjoyed it a lot.
Thank you, Ross. Thank you so much for your presentation. All right. Anyone got any questions? Yeah. Marco, maybe first.
Okay. Ross, thanks for the thanks. A question around the mechanical field. It is because it's constant timing, if you like, on the up and down stroke. Have you considered putting some kind of analog pot in the foot pedal so that he can vary the speed by, instead of the knob, essentially putting what's in the knob in the foot pedal, so how far down he presses it makes it go faster or slower? That might give him the opportunity to vary it as he goes along.
Yeah, right. I have thought about that. Yes, I haven't done anything about that thought, but I have thought about it.
Okay.
It may get down. The problem with that is you'd have to be quite precise in how well you held it, because if you varied the position of the pedal, you would vary the tempo of strumming. I didn't include it, but Michael has sent me a video of him playing with another person, which I think is probably from his church band. Now, when you start playing with other musicians, you can't really be varying your tempo. So
right.
That's not too bad. Musicians, unless you're a really good professional, probably tend to vary their tempo a bit anyway. So that might allow him to vary tempo with other musicians, although you're probably not supposed to do it. So I think that would be a problem. It wouldn't be that hard to do. The pedal actually had a pot originally, a linear pot to control the speed of a sewing machine. I removed that pot and cut the supports out to get my micro switch in, but I could get another pedal and use the pot they had.
Well, yeah, I mean, if you want, my thoughts might be that you use maybe the knob to set a base speed, and then you can vary it slightly around that, because it's not going to be like from nothing to full speed, right? It's going to be varying around some kind of set point.
Yeah, sure.
And you can use the foot pedal to vary around the set point so that it gives it a bit more of a human feel as opposed to that mechanical feel. But you're doing great. So
yeah, absolutely. Yeah, no, good point. I'll discuss it with them when I see them next and see if that's something. Yeah, thanks. Mike.
Hi, Mike. Yeah.
The cross brain thing is rather interesting, but it sounds to me like if his left foot is not going to work for him, maybe consider another input like mouth. There are a lot of people that have mouth operated things that might be quite responsive.
Right, yeah. And I think I had discussed that as well. Actually, we had a Northwest Volunteers meeting, and I think somebody there suggested that exact thing, that one of the advantages of going electronic rather than mechanical is that you can vary the trigger's force.
I'm still suggesting you do it electronically, but it gives you a much more responsive input because you don't have the left brain or the cross brain problem.
Yeah, right. Yep. Also something I could discuss with him and see if that.
But it could be something like head movement, for instance, like the angle of the neck, or
right. Yeah.
any part of the body that he can still control that doesn't suffer from the cross brain problem.
Yeah. True enough. Yep.
Great. Anyone else? All right. It's not a question from me, but as a musician myself, I play piano and a bit of violin. So I was like very impressed with this project. Like I was like, oh, this is so cool that like everyone can just enjoy music no matter what your ability is. And like this is amazing. So yeah, thank you, Ross, for this project and for the presentation meeting. Thank you so much.
Thank you.